Alright, we're going to move on to chapter 4. It's about equations of linear functions. So we're still talking about lines, but now we're going to talk about a couple more equations rather than just the standard form that we did before. So the first section is about graphing equations in slope-intercept form. So by the end of this lesson, you should be able to write and graph linear equations in slope-intercept form, and then you should be able to model real data with equations in slope-intercept form. So let's remember what that is. An equation in the form of y equals mx plus b, where m is the slope and b is the y-intercept, is in slope-intercept form. So this is familiar. We've talked about this in class. You definitely talked about it in 8th grade, a little bit in 7th grade too. These variables m and b are parameters of the equation. If I change the m, it changes the steepness of the graph, and if I change the b, it changes where it is on the y-axis. Make sure that when you're telling me things for this, slope is always just a number. So don't tell me that this slope is 2x, because slope is only the steepness of the line, and we have to describe that with a number. Your y-intercept looks like 6 in this equation, but if I asked you for the y-intercept, remember that this is a point. So you need to tell me that it's 0, 6. And it's over here on the graph that it's 0, b. But remember, y-intercept is not a number or an equation, it's a point. So write an equation of the line in slope-intercept form with a given slope and y-intercept, and then graph it. So we have this equation. Remember, m is our slope, b is our y-intercept. So if we plug this in, we get y equals negative 1/2 x plus 3. Now most people have remembered how to graph this, but just in case you don't, this is always your start. Because remember, this is a point, 0, 3. So I'm going to start at that point. And then slope, remember, is how steep the line is. So this is also our rate of change, or the change in y divided by change in x, or we can think about it as rise over run. Remember, all of those things mean the same thing. So if I have negative 1 over 2, that means I'm going to rise up 1, or negative 1, sorry, so I'm going to go down 1. And then I'm going to go right 2, because that's the positive direction. So down 1 over 2, and there's a new point. Remember, you only need 2 points to make a line, but I would suggest making some more just so you can make your line nice and straight. I could even go the other direction, as long as I make one of these negative. If I go up 1, to counteract that positive direction that I went in, I need to go left 2. So up 1, left 2 would also be on this line. And then once you feel like you have enough dots, all you got to do is connect them. Remember, no dinky lines, draw them through your entire graph, and draw them with arrows at the end. So let's try this one. Slope of negative 3, y-intercept of negative 8. So remember, we start with y equals mx plus b. My m in this case is negative 3, and my y-intercept is negative 8. So when I go to graph this, remember that we have, this is a point. 0, negative 8 is on my graph. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. It'll be down here. And then my slope is negative 3, which is really negative 3 over 1. So that means I'm going to go down 3 and right 1. If I go down 3, I'm really off my graph. So instead, I'm going to use that little trick and go up 3, but then I'd have to go backwards 1 or left 1. So up 1, 2, 3, backwards 1. 1, 2, 3, backwards 1. Now we can connect the dots just like we did with the last one. So sometimes you'll be given things that are in standard form like these two. You can graph them in standard form, or you can convert them to y equals mx plus b. It does not matter which one. I personally think standard form is easier because remember, for standard form you can kind of make just a 2-column table. And if I plug in x equals 0 first, remember this disappears. And then all I have to do is divide both sides by -4. And I end up with 1 point, 0, -3. And then I can do the same thing by plugging in 0 for y. This disappears. And if I divide both sides by 3, I get that x is 4. So over 1, 2, 3, 4. Connect the dots. And I'm done. But what you could also do is you could take this equation and you could manipulate it. 3x minus 4y equals 12. You could put this into slope-intercept form, which means that you would want to get your x's over here on this side. And you want to get y alone. So I'd have to divide everything by -4. And if you do that, you end up with y equals positive 3/4 x minus 3. And if we graph it using the tools that we just learned, remember we start at our point, which is 0, -3, which is right down here. And then up 3/4 would lead us to this other point. So it makes the exact same line, and it doesn't really matter. I personally like this better. But maybe if this number here was like 11, I know that if I divide this by 3 or divide this by 4, I'm not going to get nice pretty numbers here. So maybe I would put it in y equals mx plus b for something like that. I'm actually going to leave this one for you to do as part of your can you prove it. And I want you to choose either leaving it in standard form and finding the intercepts, or doing it by putting it in y equals mx plus b form and graphing it that way. So except for the graph of y equals 0, which lies on the x-axis, y equals 0 looks like this. All horizontal lines have a slope of 0. They're graphs of constant functions, which can be written in slope-intercept form as y equals 0x plus b, or just y equals b, because remember 0 times x is just 0, so we don't really need that. B can be any number. Constant functions do not cross the x-axis besides this one, because it's on the x-axis. Their domains are all real numbers, but their range is just that one value. Remember, vertical lines have no slope, so equations of vertical lines cannot be written in slope-intercept form. Remember, vertical lines do this, and their equations are x equals stuff. So horizontal lines have a slope of 0. That's why we can write them like this. But remember, we don't bother writing that. So if I want to graph this equation, I definitely know it's horizontal. And I'm going to find where y equals 5. Now, one thing that a lot of people do once they find y equals 5 is they draw down like this. If you think about that, you included y equals 5, y equals 4, y equals 3, y equals 2, all the way forever and ever. I only want y to equal 5. That's it. That's all it can be. So when I count 1, 2, 3, 4, 5, right here is where all of my y values equal 5. And that's it. Because it doesn't matter what your x value is, you go up 5 for every single one of these points here. So this next one, I need to put in y equals mx plus b form. So that means I need to get y by itself. So I'm going to divide both sides by 2. And I get y equals 1/2. Now the clue to know that this is a horizontal line is that there is no x's here. When you have something like this, you have no x's, so you know it's going to be flat. So I'm going to find where y equals 1/2, and then just like before, draw a nice horizontal line. So last part of the notes, a real life application, so a story. The Band Boosters are selling sandwiches for $5 each, and they bought $1,160 in ingredients. Write an equation for the profit made on N sandwiches. So remember, profit is how much money you make. And this is how many sandwiches we're going to buy. So our profit is going to equal some relationship with our sandwiches. Now, because this is in the y equals mx plus b section, we know it's going to be something, and instead of x, they told us to use n, like this. So we need to find two things here. We need to find our slope, and we need to find our y-intercept. Remember, we have many different names for the word slope. We have called it rate of change. We've called it our common difference. And we could use like rise over run if we had a graph and stuff like that. But it's also the constant of variation. So think about what that means in this equation. What is the thing that is changing? If you look here, it's going to be the number of sandwiches. And the number of sandwiches are going to cost us $5 each. So we're going to make $5 for every sandwich we buy. Now this other number that we were given in the equation is obviously our y-intercept, but stop and think about the problem. Our profit is how much money we make. So if I add this on here, it's saying that I'm making $1,160. But instead, I had to purchase that much. So what I need to do is, instead of add this, I need to subtract this money. So if I only sell like 10 sandwiches, I'm not making any money back because I'm only going to make $50, but yet I spent all of this money here. So once we have an equation, we can graph it. That's the next part. Oops. We can make a really rough sketch of this. We're going to start down here at 1160. And with a slope like 5, up 5, over, we know that we're going to end up with a huge number over here. Now to find this number over here when we're making our rough little graph, remember this is your x-axis. So at this point, y, or in this case p, would be 0. So let's find this so we can make our graph look nice and neat. So I'm going to add 1160 to the other side. And if I divide both sides by 5, I end up with n has to be 232. So stop and think about what that means. Down here, this is if I sell 0 sandwiches. I make negative $1,160 because I bought ingredients. Now up here, if I sell 232 sandwiches, I make $0 because that's right where I break even. So any sandwiches above 232, I'm going to start making money. So then it says find the total profit if I sell 1,400 sandwiches. So I want to know the profit if my n is 1,400. So this just becomes a calculator problem. If we do 5 times 1,400, I end up with 7,000 minus how much I spent on ingredients, and we end up with the fact that we made $5,840. So you have a few problems to do on your own, the one that I left back there, and then these two, and then this one couldn't fit down here, so I threw it up there. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.